All right, so let's look at this last unit, our last video together. We're going to look at the two discounting cash flow methods that we use to evaluate capital budgets, make capital investment decisions, net present value, and internal rate of return. So net present value, or NPV, is a method that examines the difference between the present value of the net cash inflows and the present value of the net cash outflows. Now we use for our interest rate what we call a discount rate. The discount rate is management's required rate of return on capital. So that's what we talked about, how management's going to say, ooh, this is a risky investment. I'm going to assign it a higher interest rate or higher discount rate. Instead of discount rate, you may also hear it called a hurdle rate, a cost of capital, the required rate of return, sometimes even the nominal rate. Any of those words are used interchangeably. So we're going to look at two different projects here. We have the option of buying some laptop computers or some desktop computers. And for both methods, the initial investment, for both investment packages, the initial investment is $1 million. I don't think I have that written down here, but I'm going to write it down right now. So the initial investment is $1 million for both. So we can see that the net cash inflows for the laptops are $305,450,000 every year for 5 years. Since this is the same every year for 5 years, we're going to use that annuity table. Now for the desktops, notice that the amount is different every year. So since it's different every year, we can't use the annuity table. We're going to have to do this one all in the single sum table, or this $1 table. So let's look at the laptop project. Now, this table that I've got written out here is a table that I created to help me solve and organize these problems. This is not a table you're going to find in the book. This is not how you're going to see it set up in my accounting lab. So I would encourage you to work your homework problems out by hand. I've always encouraged that, and then input it into my accounting lab. But I find that this chart helps us organize it, and we do better than when we just kind of try to randomly do something with the numbers. So first of all, it doesn't actually matter what order you put the cash flows in the table, okay? But the way I like to do it is to start with the initial investment. Now we said that the initial investment always happens in year 0. So in this case, in all cases, the initial investment is an outflow. So I like to go ahead and designate that right there. So the cash flow amount, our initial investment, is $1 million. Now, you could look in your factor for year 0 and you'll find that the tables, this is referring to the table factor, isn't there for year 0. So the present value factor for year 0 is always a 1. You can put a 1 in there, you can leave it blank, you can put a dash, it's up to you. So then we calculate the present value by saying 1 million times the factor of 1, which gives us $1 million. Now, since this is an outflow, I'm going to put it in parentheses because I want to treat it as a negative number. It is a cash outflow. So the next I have is the annual net cash inflows of $305,450. Those happen every year, years 1 through 5. They are an inflow. Since they happen every year 1 through 5, that's my clue that I'm going to look those up in the annuity table in a minute. The cash flow amount is $305,450. So now I'm going to go to my annuity table and I'm going to look up my factor here. Now, the interest rate is 14%. This is what management tells us is our required rate of return. So I'm going to go to the annuity table. I'm going to look up 14% across the top. I'm going to look up 5 years across the rows, across the side, and I get a factor of 3.433. So when I crunch those numbers, when I multiply out 305,450 by 3.433, I get a present value of 1,048,610. Now, because this is an inflow, I'm going to treat it as a positive number. Now, I didn't have any other cash flows in this project, so I'm going to draw my line to subtotal. I'm going to add these two numbers together, and I get NPV is equal to 48,610. So let's talk about what this means and what this doesn't mean. This does not mean that the profit of the project is 48,000. This does not mean that the project is going to bring in $48,000 in cash. Okay, actually it's bringing in 305, 450 every year for 5 years. Okay, what this tells me is that the project returns 14% plus 48,000 on top of that 14%. So the 48,000 is the additional return on top of 14%. If the project returned exactly 14%, then NPV would be exactly 0. Okay, so you have a decision you have to make. You're going to be asked whether accept or reject this project. In this case, we would want to accept, and our reason why is NPV is positive. NPV is the project is going to return the minimum of 14% plus it's going to return 48,610 on top of that 14%. So our decision rule is that if NPV is 0 or positive, we want to invest in the project. We want to accept. Okay, because remember, NPV of 0 is exactly 14%. This means they exactly met management expectations. We're happy. If the NPV is negative, we do not invest. Now, a negative NPV does not mean that the project is not profitable. An NPV that has a rate of return of 13% will have a negative NPV. Now, 13% is still a lot of profit, but it's not enough profit for us to accept this level of risk. So we would reject it even though it was a profitable project. So now let's look at the desktop project. Now, since the desktop project had unequal cash flows, we can't use the annuity table. So we're going to have to look up each year's cash flow individually. So I'm going to ask you to pause the video and you try this one, keeping in mind that the interest rate is still 14% and our initial investment is still $1 million. Try it and then come back and we'll talk about it on the next slide. So we're going to start with our initial investment of $1 million. Since that is an outflow, I'm going to treat it as a negative. And then I'm going to go to year 1. So I'm going to look up 1 year, 14%, and in the present value of $1 table, and I get a factor of 0.877, and I multiply that out. And then I'm going to go to year 2 and look up 2 years, 14%, and I get 0.769. And then year 3 and year 4 and year 5. And when I multiply all of that out and add up all the numbers and subtract the million, I get NPV of 78,910. So what this means is that this project also returns at least 14%, but it returns $78,000 on top of the 14% instead of $48,000 like the laptop project did. Now, I want to point out just one little thing first. You notice in the annuity table that after the first year, all of the factors are greater than 1. The way they get the factors is they just add them all up. So if you were to add all these up, guess what you would get? 3.433. So that's how, when it's all the same, when the cash flows are the same every year, you can just multiply the cash flow by the sum of all of the present value factors. That's that distributive property that we learned in algebra and geometry. Now, since our cash flows are all different in this example, we can't do it that way. It doesn't work. It only works if the cash flows are the same every year. So we would want to accept the desktop project also. They both have positive NPVs. They're both going to be profitable projects. Now, what if we were told that the laptop project would have a residual value? So here we're told that at the end of 5 years, we're going to sell the laptops for $100,000. I realize selling laptops doesn't really make a lot of sense. So maybe it's something like we're going to donate them and get a $100,000 tax write-off or something of that nature. So now let's look at doing the NPV under this scenario. So we're still going to start off with our initial investment, which happens in year 0. It's an outflow of $1 million. In year 0, the present value factor is always 1. So that means my present value is $1 million. And since it's an outflow, I'm going to treat it as a negative. So this is the laptop project. This is the one that has the same cash flow every year. So every year, years 1 through 5, I'm going to have an inflow of $305,450. I'm going to look up 14% in my annuity table in 5 years, and I get a factor of 3.433. And I multiply that out, and I get 1,048,610. But now I have to deal with that residual value. So first of all, remember the residual value happens at the end. So this is going to happen in year 5. It is an inflow. It is money that I expect to receive. I expect to receive $100,000. Now, since this is happening one time and one time only, I'm going to look this up in the present value of the single sum or present value of $1 table. So when I look up 14%, 5 years, I get a factor of 0.519. So when I multiply that out, that comes out to 51,900. So now when I add this up, I get 100,510. So in this scenario, the laptop project would return the 14% plus an extra 100,510 on top of that. So the thing is, NPV doesn't tell us what the actual rate of return is, okay? We know that it's more than 14% because we're getting $100,000 on top of the 14% return. But we don't know exactly what it is. We'll come back and discuss that more in a little bit. Now, when you have multiple projects that have positive NPVs, it can seem like, oh, I should just choose the one with the highest NPV. And if the initial investment amounts are all the same, that's exactly what you can do. So in our laptop and desktop project, since the initial investment was $1 million for both, that's what we could do. We could say, oh, well, we want the laptops with the $100,000 residual value at the end. That has the highest NPV. But if the initial investment amounts are different, you can't just look at what the highest NPV is. You have to take it an extra step and calculate what's called a profitability index. So here we have 3 projects. Project A, which has an NPV of 25,000, Project B, which has an NPV of 38, and then Project C, which has an NPV of 32. So looking at this, I would think, oh, I want to accept Project B. It has the highest NPV. However, notice that they all have different amounts of initial investments. And since they have different amounts of initial investments, I've got to go ahead and calculate that profitability index. So the profitability index is really easy to calculate. It's just the present value of the net cash flows divided by that initial investment. So when I look over here, I have Project A. I'm going to take the present value of the cash inflows divided by the initial investment. That gives me a profitability index of 1.2. For Project B, I'm going to say 238 divided by 200 gives me 1.9. And Project C is 182 divided by 150. That gives me 1.21. So now looking at the profitability index, I really want to accept Project C, not Project B. Even though Project B had the highest NPV, it also has the highest initial investment. So it's only returning, if we look at it, $38,000 over the initial investment, whereas project C is returning $32,000 over the initial investment, but your initial investment is lower. So it's a higher percentage of it in total. So in other words, Project C is returning 121% of the initial investment, whereas Project B is only returning 119% of the initial investment. Actually, looking at this, Project B is the lowest of the three. So we would want to accept Project C in this scenario. So if we look at the profitability index of the laptop and desktop project, now we didn't have to do it this way because the initial investments were the same, but notice that they come out the same way, where excluding the residual value, the desktop project, it has the higher profitability index. Now, let's talk about internal rate of return. So internal rate of return is essentially the interest rate that sets NPV to 0. So this is approximating what the actual rate of return of the project is. So NPV will tell us whether it's higher or lower than management's required rate of return and how much extra money, cash dollars, we would earn on top of it, but it doesn't tell us what the actual rate of return is. IRR is a approximation. It's not a real, but it's an approximation of what the actual rate of return is. Now, there are different ways to calculate IRR. I'm going to teach you how to calculate it using the tables. When you get to those upper level finance classes, you'll calculate it using a more complex formula. So looking at our laptop project, we know that it has an initial investment of $1 million with the yearly annual net cash flows of $305,450. So to calculate the present value, we're going to, to calculate the IRR, we're going to take the initial investment divided by the annual cash flow. So in this case, we would take 1 million divided by 305,450. So when we do that, we get 3.274. Now, 3.274 is not your answer, okay? 3.274 is your annuity factor. So now you're going to look in your annuity table. So you're going to pull out your present value of annuity table. We know that this project is 5 years, so you're going to look along row 5 and you're going to find the factor that is closest to 3.274. So when you do that, you will find that the factor of 3.274 is closest to the factor in the 16% column. So we are going to approximate IRR by saying that it is 16%. Okay. Now, I will tell you, you will not always find the exact table factor in the table. Again, you're going to choose the one that it is closest to. It's just an approximation. So now let's go through and calculate NPV using 16%. So if I were to calculate NPV using 16%, I would take the 16% multiplied by that 3.274, which gives me present value of $1 million, subtract my initial investment of $1 million, and guess what? NPV is 0, or approximately 0, really close. There was a little bit of rounding, but it's right at 0 because IRR is the interest rate that sets NPV equal to 0. So our decision rule is if IRR meets or exceeds management's required rate of return, we want to accept the project. If it doesn't, then we don't want to accept the project. So this brings us to the end of our class. I hope you've enjoyed it. I hope you've learned a lot. Please keep in touch. Let me know what great and fabulous things that you go on to do. And I hope that one day I do get to meet you in person. Before we close out, I just wanted to show this one last slide that I added in here at the very last minute, but I really like this decision tree where we think through our capital rationing and capital decision making. So it's just a useful tool.